Welcome to Academic Digest class. In our last class, we did simple harmonic motion. Today we are doing examples of simple harmonic motion, and today's class, one of the examples is simple pendulum. So we know that we have compound pendulum, we have simple pendulum, but when we have a thread and we have an object of mass, a simple version of pendulum, such that I consider a case where I have a fixed point, which is where my force is, and I have the thread attached. When this object swings, it will come to a point where the object will be this way. Then as it moves on this other end, once I have this, there will come a point. So if I release it to move this way, then get to this point, then come again. Then notice that if that is the case, there's an angle made here, which is theta. There's an angle made here, which is theta. So we can say that simple pendulum is that type of, or then collectively I can say that everything here is theta. So I can say that simple pendulum is that type of motion that involves an angle with the vertical. And remember I told you that in normal motion, in normal vectors, if I have a triangle, if this side is theta, if it's pointing here, notice that for example, so ka, the two have edge in common, cancel it, no business. So whenever I'm considering sine, I'll be considering that whatever side is opposite. That means that whenever I'm talking about sine, I have to look at the side that is opposite. And whenever I'm considering cos, I have to look at the part that is adjacent. So notice that whenever the angle is with the horizontal, the side facing that theta is the opposite. And notice that this is a vertical line, so y is always sine when the angle is with the horizontal. So y is always equals to sine theta when it's with the horizontal. And then what is remaining, the side that is not touched, that is no opposite, and there is no hypotenuse, this side now, that means x is always the cos theta for when the angle is with the horizontal. But now consider a situation where I have this, and then let's say I have theta here. Remember I told you always ignore the edge. So notice that sine and opposite deals with so and adjacent and cos. In fact, anytime you talk about opposites, it means you are referring to sine, the part that is sine, and any side that is adjacent refers to the cos. So notice that if this is the angle theta, which side is the opposite? This side. And notice that anything here is x axis. So when the angle is made with the vertical, x is always the sine theta. That means the remaining side is always the cos theta. So that means that a case of simple harmonic motion, simple pendulum, case of simple pendulum, notice that this is angle and is looking this way. So let's say from this end now, to this end, notice that the force that will be acting here is gravity. So let's say the height here is h, from this object to this is h. That means that from this end up to this end is the length L, because that thread is length. We'll consider here that thread will swing this way, so is the length. So which means that if this object at this point as is moving this way, this angle is closing. Now remember what I taught you, ASTC, that towards the angle you use cos, away from the angle you use sine. So if this thing is moving this way, notice that it is going to be closing. So this particular object, this particular length L here, when it gets to this y, the vertical component of this y axis is that this angle will be closing. So that means if you want to consider it, you can also say that that means that y here is L, that is the length of this cos theta. But if you can't remember this, you remember that since the angle is facing this way, notice that this angle is facing this x-axis, horizontal line, facing this, and if it's facing this, that means that x itself is L sine theta. Since we are talking about length of thread, this is L sine theta, the x, while this side is L cos theta. So if I know this, if I've noted this, it simply means that this edge, notice that this edge, that is the height from this object, the highest point, this is the highest point to the lowest point, which gives me edge, is simply going to be equals to, edge will simply be equals to this L, the total length, minus this L cos theta, that is this part, minus L cos theta. That is the same thing as saying this is the whole L now, shebi. If I come and remove this L now, if I come and remove this part now from the part that has to do with weight going down, if I remove this part, this from this end to this end, from this, I should be having this remaining. So that is why I say that H is equals to this. So now notice that the force that will be acting here is mg, and the force that will be acting here is, that is on this object downwards, is also mg. So if this particular thing is swinging this way, notice, if it's swinging this way, notice that at this point, that this thing is swinging, is on the horizontal axis, so notice that is the center. Since I have this moving this way, I'm moving this way, and I have theta this way, and I know that this side pointing this way is my sine theta, and this side is my cos theta. But because I'm considering length here, I use L cos theta. Because I'm considering length here, I use L sin theta. Now when I'm considering force, which is going downwards, mg and mg, I'm no longer going to be considering L. Rather, I will be considering the force and the component on this, so that the component on the x-axis is sine theta. Component on this is sine theta. So which means that the force on a simple pendulum is simply equals to mg sine theta. And notice that because of the fact that it is going in opposite direction to the force, because this is the force, it moves this way, the force will drag it back. It moves this way, the force will drag it back. So I'll put minus here. So which means that it's something as saying MA equals to mg sine theta. So m cancel m, A is equals to g sine theta. And you need to note that if this is a circle, when we learn circular motion, and I have this and I have this, if this is r radius and this is theta, that the position from this end to this end is s. And notice that this theta now, the side facing it is this s. So we can say that theta is equals to s over r. So we can say that, sorry, sine theta, because remember we said that so refers to anything opposite to something. Is you are talking about sine. So this s is opposite to this theta. So sine theta here is simply s over r. And in simple pendulum or simple harmonic motion, s is represented with x, and r is represented with L. So theta is equals to x over L. Or if I'm considering this displacement to be on the y-axis, I can say that this is something as in theta equals to y over L. And if I'm considering this to be a maximum displacement, I can say theta equals to A over L. So whichever way, that is the same thing. And notice that this is talking about the angle. So that is the same way I said that time, that A acceleration is the same thing as w square x. If I'm considering the displacement in x-axis, A equals to w square y. If I'm considering this acceleration in y-axis, or displacement, yes, acceleration or displacement in y-axis. And if I'm considering maximum displacement, acceleration will be w square a. If I'm considering the radius, it will be equal to w square r. So now that I know this, I'll simply say, okay, if that be the case, I've been able to get this. If I want to now get, using the things I've analyzed here, if I now want to get the period or velocity at lowest, okay, let me first get velocity. So if I want to get velocity at the lowest point, or speed at the lowest point, I will simply say that at the lowest point, kinetic energy is equals to potential energy, and potential energy is mgh, while kinetic energy is half mv square. So what I will just do here is to cancel the m's, so that, remember, the h here in simple pendulum is simply L minus L cos theta. So I'm just having g. So I now have half v square is equals to this. So these two will come here, so that I now have 2g into L minus L cos theta. So I have v square. So take the square root of both sides, so that I now have that v is equals to root 2g into L minus L cos theta. So anytime you are asked to find the maximum displacement, the maximum velocity, anytime you are asked to find the maximum velocity of a simple pendulum, or Remember, I did not say simple harmonic motion. Simple harmonic motion, maximum velocity is just AW. But anytime you're asked the maximum velocity of a simple pendulum, or you are told to find the velocity at the lowest position, because this thing that you see here, if this thing swing now, this point is the lowest position, this is the highest position. So at this point, that's where you have the maximum kinetic energy. At this point, you have the lowest kinetic energy. Lowest, zero kinetic energy. At this point, you have the most potential energy, no movement. Most potential energy. At this point, you have zero potential energy. So when they ask you lowest point is this point, and the formula to use to calculate that velocity or speed is simply V equals to root 2G L minus L cos theta. Very simple. Now to find period, using what we've done here, to find period will simply mean that we are going to be having, from simple harmonic motion, period is equals to 2 pi over W. So, and we know that considering what we have, F is equals to minus mg sine theta in simple pendulum, and sine theta is the same thing as S over R. In fact, if you remember theta, that time we did S equals to theta R. If you made theta subject of the formula here, theta is equals to S over R. So if you consider it, if this is your circle, this is your radius, and this is your theta, this is displacement S, the side opposite it. Remember what I taught you when we started. So I'm taking this now to mean X, taking this to mean L, because in simple pendulum or harmonic motion, we'll consider displacement to be X or Y, consider radius to be L, that is length of that particular thing. So if I put it together, and I have that MA is equals to minus mg x over L. M cancel M, so I have A is equals to minus g x over L. Alright, now we remember that acceleration is equals to minus w square r, if you remember. Yes, so if I remember this, and I say that since we are considering acceleration in x-axis or y-axis, and we already used x for our displacement, that means that this is going to be w square x. So if I put this together, I will now say that acceleration, since I have x here, in terms of x, acceleration in terms of displacement is simply the second derivative of displacement with respect to time, equals to minus w square x. So I can simply say that this thing now is the same thing as saying d square x all over d square t, crossing over, plus w square x equals to 0. This is an equation, the popular equation for simple harmonic motion, but it's actually for simple pendulum, and simple pendulum is an example of simple harmonic motion. So if I know this, I can now say, okay, at this point I got that acceleration, look at these two things, acceleration is equals to minus gx over L, acceleration is equals to minus w square x. So let me put it together, minus w square x equals to minus gx over L. X, take care of x, so that I have minus, take care of minus, so that I have that w square is equals to g over L, which means that if I want to make w such a formula, I'll take the square root of both sides. So it's important you notice somewhere in future, for sake of solving, that w square is equals to g over L. Very important. And then w itself, now this will cancel this, so that I now have that w is equals to square root of g over L. Very important. So if w is equals to square root of g over L, I can now say, considering simple simple harmonic motion, that 2 pi over w is equals to t period. So I can now say t equals to 2 pi, replace w with square root of g over L. And you know that if that be the case, this time becomes 2 pi divided by square root g over L. And you know that if I choose to put this to become multiplication, I will reverse it, so L over g. So t is equals to 2 pi root L over g, which is the normal equation you know for period of a simple pendulum. Now if you have frequency is equals to 1 over t. So the frequency of a simple pendulum is simply F equals to 1 over 2 pi root L over G. This one is for this, and this is also for this, which gives us that F is equals to 1 over 2 pi root G over L. Very important. That is, it's the same thing as saying I have 1 over 2 pi, because this thing now means the same thing as saying 1 over 2 pi times 1 over root L over G. So I can reverse this. Now to mean this G coming up, and I can reverse this to mean 2 pi all raised to power minus 1 then root G over L, whichever one, but that's your frequency and is in hertz. So if I know this, I've been able to get the period and the velocity of a simple pendulum. So remember, if somebody now asks you what is the force of a simple pendulum, it's simply F equals to minus mg sine theta. And if somebody asks you what is sine theta in simple pendulum, sine theta is simply equals to S over R, and it's something as saying X over L. Then remember these facts. A simple pendulum is that type of motion that has this theta this way, and whenever theta is facing down, the side is facing is the opposite, and whenever you're talking about opposite, you are calling that side sine, and that means that the remaining parts, this side now, because if this side is sine, everything is sine, that means that this part becomes cos theta, and we are putting L because we are talking about length, so this one becomes L. Now when we are considering the force of the objects here, so it's now going to be force mg, and then considering the sign that it is going is sine, this side is sine, so put sine theta to it, very important. So if I put this sine theta, now when this object gets to this particular point and gets to this particular point, there is mgh, that is considering the force and the heights, because remember what this is force times displacement. Now that is work done in this place. Now is going to be force, that is mg for force, yes, then times displacement, in that case is the h, because it's happening at a height. So that means that this part becomes my, this point to this point becomes my h. Then that means that everything here from this end to this end is my L. So if I know that, thank you very much.